Hello, everyone. My name is Julian. I'm the president of the GDN, which is the Game Development Network, if you're not familiar. Today, we're going to be doing a continuation of our previous talk. Our previous one was for beginners. It was just how to open the engine, how to turn on a computer. This is going to be more of an intermediate level kind of class. We are going to talk about building a UI in Unreal. So, of course, you got to have the engine. If you didn't download it Friday, make sure to download it now. We're going to be using 4.27, but really anything like 4.10 back, you're probably fine on. I'm going to go ahead and I've actually already made a project. We're going to be doing everything from scratch anyways. I'm just going to have a project open just so I can check my notes, basically. Okay. Here. Oh my God. Someone joined, which means I wonder if I should give the intro again.
Sup, Varun?
Sup?
Okay.
Wait, is this an online one only? I'm just curious.
Yes.
Yeah, I don't
turn
want
out.
that person. You're literally the only person here. If you have any questions, just interrupt me. Like, you're good.
I'm also technically a Flex member, so I just came in because I'm interested in this, but I'm excited.
Okay, so building an Unreal UI. So first, Unreal has a lot of like gimmicky terms that you have to just be familiar with. There's a thing called a widget. I don't know why it's called a widget. It doesn't matter why it's called a widget. I have a folder here called widgets. I normally name them BPW for Blueprint Widget or WBP for Widgets Blueprint. Which again, if you're not familiar with blueprinting, check out our previous talk. So let's go WBP _ big widgets. Is when you're making Unreal UIs, the best thing you can do is make one thing that's going to actually be on the screen and sort of act as a container for a bunch of other smaller widgets. We're not going to be doing that a ton today, but it's just a good habit to always be making. And you know, when you're working on a complex UI, you have it available. All right. So when you make a widget, you're going to get this. It's pretty similar to the blueprint editor. And actually, if you press this button called graph here, it is a blueprint editor. But we're going to be using designer first and just kind of talking about the different buttons here. So a palette is everything you could possibly drop into the screen space. So the example here, there's common, which is what Unreal considers sort of like the best always to have on your tool belt. Really nice to know things to drop in. There's the editor stuff, which really you should never be touching unless you're really good at Unreal. Input, if you want to have someone type in something and then actually use something for that data, or you can have someone type in something and never process it. That's also fun. Optimization, again, you can probably guess what that does. It's very complicated though, not really for a student level project in general. And then user created, we were talking about having a bunch of widgets in widgets. If all the widgets you make will pop in here. So if I do, you know, user interface, WBP _ show me. I come back here and I just recompile. I can drop this in there and it's an element I can interact with and switch through and whatever. Which, yeah, I guess I should explain that real quick. Adding things to the viewport. So if I grab it and drag it, it's in the viewport. When I play the game, it's going to be anchored to wherever the anchor is. If you're not familiar with anchoring, basically it'll be a certain amount of pixels away from a part of the screen. So if I'm top anchor and I set it to 0, 0, no matter what resolution we're playing the game at, it'll be at 0, 0 relative to the top of the screen. So it'll kind of just interact with the top of the screen. If you're playing on a phone, it'll be on the top of the phone. If you play on a big 16:10 desktop, it'll still be there. This is normally really important to master early because, yeah, you're going to be looking at this on a 16:9 monitor for like 90% of your time as a developer. And Unreal defaults it to a 16:9, although you can change that. You can grab anything. If you want to make something for the iPhone 5S, that's what the scale looks like. There you go. But, you know, pretty much everyone uses a 16:9 monitor. 22 inches is pretty typical. You can also, if you want to, you know, I work on a 4K monitor, so you can even do that. But anyways, let's go back here to just typical like 16:9 monitor. There. But let's say you want something like in the center of the screen, and then it should be anchored to the like a crosshair. It should be anchored to the center, which again, if it's 0, 0, it'll be at the center. If it's do 500 pixels on the X, it'll be 500 pixels away from the center. I see a message in the chat. Unreal, yeah, Unreal supports every resolution. Like, but you have to be a good UI designer for it to look in any way competent. Because if you try to take a 16:9 and just stretch it to a 21:9, it's going to look super weird. And so again, that's why you have to kind of anchor things. Of course, also your game designer has to actually, like, you know, program the camera to expand the FOV or to zoom out, which not all games do, but yeah, it's the engine supports it if you want it. All right. And so yeah, that's dropping things in. Just to go through the common list, which I feel like, again, if Unreal says they're important, they're probably important. Borders are a space to drop something in. So it's a border. I mean, you can kind of get that. So if I put a button here, I can actually put it below here, and now it's part of this. If I make this invisible, they're both invisible. If I make the border red, it'll make the button red, like that. Simple stuff. Buttons are extremely important. They're interactable, and we'll get into interacting with stuff probably 15 minutes from now. But you can adjust everything with buttons. Just memorizing everything on this list will take you a good bit of time. So you can change the color when they're stagnant. You can change the color when they're hovered over with a mouse. You can change the color when they're pressed, and you can even like fade them out if the player can't use the button. Like if you're doing a crafting menu and they have to pick a certain number of elements, you can fade it while they haven't picked them yet. You can put sounds for when they're pressed, change the color, etc. And then we'll get into that later. But yeah, buttons are great. Checkboxes return true or false. So if a person hits a checkbox, it's true. If not, it's false. Very similar to buttons in terms of how you can use them. Images are just the raw, like PNG or Targa. These things are expensive. And so basically, if you're one of those people who likes to do everything in Illustrator or what software do you UX kids use?
A lot of Figma, yeah.
Sure. If you want to do it all there and drop it in and just put the buttons over it in terms of programness and like don't color and just make the buttons completely transparent, that's how you'll do it. And just make sure you talk to your programmer if you're making a game where the UI kind of always needs to be ready to go, because those images have to be loaded into RAM. Something that's kind of confusing. So the size here is the actual size of the image, right? In terms of how much space does it take up in the screen. But then under brush, whereas where you set the image, this is where you set the resolution of the image. So even if I put a high res image here, I don't have anyone on me, but if I put like a 4K image here and I put 32 by 32, it is going to scale the 4K image down to 32 by 32 and then back up to 256 by 256. So make sure you change those values when you're dropping your images. Another thing,
what would you set it to? So the image size would be set to the original file size?
You just got to type it in. So if it's a 1024 image, you just type in 1024.
Okay, perfect.
Yeah. Computers always have to scale things to powers of 2. If you have an image that's 900 pixel wide, you just should make it 1024 anyways, because the computer is going to have to do that on its end. So you might as well just take the extra pixel space and get a little higher res image. So 2, 4, 8, 16, 64, 128, 256, 512, 1024, 2048, and 4096. Those are reasonable things. Don't do an 8K image. It's worthless. No one's going to have an 8K monitor to pull it up on. All right. Name slot, I've never used. Irrelevant. Don't worry about it. Progress bars are awesome. They're great, especially like they're very gamey, but you can do like health bars or ammo, anything like that. And you can set the color here in appearance. So, you can do that. You can also change that for an image and make it a gradient. And we'll talk again about how to code it in just a little bit. Rich text blocks, don't worry about them, not important. Just use normal text blocks. Sliders are pretty specific in use. They're really only for like volume sliders, essentially. But they will take an input from 0 to 1. And so if you're doing like a volume from 0 to 100, you have to multiply it times 100 on your end, because it'll just be a 0 to 1 value. And then text is great. It's text. You can import fonts simply by dragging them into Unreal. And it'll say, do you want to convert this into a usable font? You just say yes. And then it'll be available for you. And then that would be under fonts, and you can just change it here. And those are the commons. We talked about adding things to the viewport. There's one other thing we should talk about probably, which is a render transform. So you can super sample and subsample things. Let's say you really want something to just look crisp, but it's not going to take up a lot of space on the screen. You could do a high-res image and then scale it down to like 0.5 scale. So this text is still 24 size font, but it's just been scaled to 12 size font space. And now it's going to look really nice. Again, there's a performance cost to it, but if you're making like an app, probably not a big deal. Okay, and that's most of that. Please, either of you, if I'm going too fast, just let me know. I'm just trying to move through things. Animation. If you've ever used a keyframe software before, Unreal is no different. So we can make an animation. It's like, all right, we're gonna grab this text. On the animation bar, first you have to just make something to store all the animation tracks. And so we're gonna call this animation storage. And then within here, we can add tracks. So we can do, okay, let's do text track, and we're gonna make one track for opacity. We'll keyframe 1, we'll keyframe 0. And so you type in the value first and then hit this little nub. So already we can see that animation being tested in real time. You can set the frame rate. I would highly recommend sticking to intervals of 30. Most people who are playing with something in Unreal Engine are probably doing it on a monitor that divides evenly into 30. If you pick a frame rate that's arbitrary compared to a monitor, you'll get stuttering. So 24 frames per second is nice for movies, but on a 60 hertz monitor, it's going to look ugly. 60 is what it's going to actually look like for 95% of people, but you can do it in 30 if you're just nervous about it. And you can do it in 120 if you really want that kind of intricate control. Doesn't matter. Just stick in intervals of 30. And let's say we want to do a second track for, I don't know, transform. So we'll do a rotation track. Back to 0, make sure we're actually keyframing correctly. Drop a nub and do 180. Drop the nub already. Let's get rid of this one I added accidentally. And so you can again see both of these animations are happening at the same time. And if you ever call animation storage, it'll play everything in the tracks. If you feel the need to call individual tracks, make them in separate storage containers. I really should zoom in, maybe showing off something this tiny. All right.
So if I want all of them to play at once, would I make a separate like container track, which would have all, like example, I make one for each of my individual objects that I want to see individually myself. But then if I want all of them to play at once, would I have to make a separate track that has all of them embedded inside of it? Yeah, so you'd have like animation storage here, and then you would just make a second track for this guy too. And as long as they're on the same storage container, you're good to go. Like they'll all play at once. If I go here, neither of them are there. If I go here, they're both there. I see. Okay. Makes sense. Okay. Binding. Binding is super important if you're ever going to be working with Unreal.
So I mean, again, it's basically, how to say this? You're going to check the computer every frame. So if the game's running at 60 frames per second, that's going to be every 16.66 milliseconds, and check a value and then update something based on that value. So for example, like health bars are again really common. If you go to the right here, this again might be a little small. I can grab my magnifier. You'll see on progress, we can actually press bind and create a binding. And we can do like, get a variable called player health. And so when player health is 0, the progress bar will be empty. When that player health is 100, it'll be 100. You can do lerps, which kind of combine two values. If if the player takes 30 damage at once and you don't want it to just dunk, drop, you can do a little animation with the lerp and just have a nice clean alpha for that. We already talked about animation. If you want more on that, just make a little animation track for the float. No problem at all. And so we'll show an example of binding. We have to code it, but we'll get to that. All right. So this is it. This is the most important thing you can learn from this lesson, the thing that will separate you from a bad Unreal designer in terms of UX and UI. Boxes. So I've been told to describe this as auto layout in Figma. I've never used Figma. I cannot tell you if that is an accurate or inaccurate comparison. But because we're working with so many arbitrary resolutions, like I mentioned earlier, anchoring it's fickle at best. I don't like anchoring, and neither should you. Instead, what we do is we create boxes within boxes. So I'm going to drag a horizontal box out, and I'm going to press the full screen anchor. So this box is always going to take up the full screen, no matter what resolution we're in. Then what we can do is we can put 2 vertical boxes and tell them to fill the space. So grab 1, grab 2, and tell this one to also fill the space. And now we have 2 vertical boxes. And now we say, okay, we're going to put in horizontal boxes within these vertical boxes. And so now I have a horizontal box. I'm going to tell it to fill the space. And keep going, keep going. And so your things will always perfectly scale to resolution if you get really good at this. To actually show some examples of that, let's do text in here. And you'll see how they perfectly fill the space. And if I grab another horizontal box, press the fill, I can tell them, okay, look, it always needs to take up a quarter of the screen. So you do horizontal box for the screen, 2 vertical boxes to divide it on the y-axis. Then within those 2 horizontal boxes to divide it on the x-axis. And now you always know it's going to be in the corner of the screen. They're really great. I love having them. If you grab this text, you can set it to the bottom. So if you need to always be on the bottom of the screen, you just set it to the bottom, this little flicker here. And now you know. If you're one of those really neurotic people who likes some padding, you literally just go into padding. You can do 10 degrees, or no, you should do it on the bottom. So 10 degrees from the bottom, 10 degrees from the left. So now you know you'll have exactly that much space. They're great. And to go even further on that concept, there's this thing called spacers. And so we have all these text blocks. They're really kind of cramped up on each other. We can put them in our horizontal box, rearrange them. So we put the spacer between 2 text blocks. And if we press fill, it'll just push it as far as it can. Otherwise, we can press auto and just do more padding. So we can do 30 degrees. And now, boom, you have perfect alignment on everything. It feels nice, it looks nice. This takes a lot of practice. Like I said, don't feel bad if it's hard to understand in this talk. Just watch this part again and practice it. Okay, and then just a last little one that I've always liked are throbbers. Throbbers are great. There's circular throbbers, Oh, that looks terrible like that. Let's do auto. Oh, it's because I put it in boxes. No more boxes for now. Let's do 256 by 256. So you'll see if we set the size, just get little throbs that fill the space. Throbbers give you pretty great control of things if I can find it. So you can change what the actual circle is by pressing image. You can put the number of pieces up to 25. Won't let me go higher than that? It won't let me go higher than that. You can change how fast or how slow the throbbing is, as well as the radius of the circle. But this one requires code, so you probably shouldn't touch it for now. People like the circular throbber. That tends to be their favorite. I've always been a fan of OG throbbers. But I mean, who cares? Like, we're talking about the most minute things here.
Animations customizable?
Yeah, completely.
Okay.
I will say it gets to a certain point where it's like, you should just animate it yourself. But, you know, let's say we only want to do vertical animation. We just do vertical. We only want horizontal. You can turn on or off opacity. It'll give you stuff like that, as well as, again, the amount of pieces and the time it takes. But it does get to a certain point where it's like, probably should just make your own. We talked about anchoring, talked about location, talked about size. Oh yeah, size to content. This is also really nice. So you can make an object and put something inside it. So we've already talked about this, border and button. And actually, border might be a poor example. This might be hard to see it. It's a border. Let's just do a horizontal box. And a button. We're gonna, once again, make our horizontal box full screen. And if I press auto, again, it kind of tries its best to just fill in the minimum amount of space it would require in order to convey this image. If you press fill, it'll fill the whole space. Getting good at this is really nice, but kind of tedious. You can do alignment. So a box of this type would be like this is like 64 by 64 pixels. If you center it, it'll fill up 64 by 64 pixels. But if you full screen it, it'll take up the full screen. Oh, okay. And this is another one where I do not understand the appeal at all, but I've been told Flux kids love it. Background blur. Probably guess what it does. It's pretty self-explanatory. So you have this background blur object in the palette. If you press apply alpha to blur, it'll work. If you don't check it, it'll not work. The reason they have that is for code more than anything else. There's no reason not to apply it. And then blur strength 0 to 100. If it's 100, it's completely unparsable image. If it's 0, it's non-existent. I like 65 for a background blur. That normally kind of conveys that, hey, there's still stuff happening behind it, but all text becomes readable. But whatever. Okay. So we have a great understanding of widgets, but how do we actually use any of this? So we're just gonna, as a test, grab a text block and put it in the center of our screen. Big, say, hello. File. And now we're going to go into any object. Really can do this. Again, this is going to assume you're familiar with Unreal's blueprinting from last session. So I'm just going to do this all in the player character, but we'll come back to that. No looking at that. So what you can do is press, or first search create widget. And all this does is create it and store it in RAM. It does nothing with it. It won't put it on screen. It won't activate any variables, just creates the widget. You have to actually choose which one you want. We're going to grab, I call this WBP. And so what you can do is just press add to viewport. You go off. And so begin play, create the widget, add it to viewport. I really hope I didn't mess this up somehow. Hello, there it is. This is bad code. Don't ever do this. Because now we can't interact with that at all. Like it's just gonna be on the screen forever. We can't play any of our animations. We can't reference it at all. So instead what we should do is make a variable. So what you do is right click here, promote to variable, and just name it something like HUD. It's our HUD, we can have it. And so now anytime coding, if we need to play an animation, say, hey, don't be on screener now. Hey, be on screener now, change the background blur. We can just drag off HUD and do those things. And now we can add this to viewport. And still there, no worries. But if I want to do on when the player presses the E key, there's the hardware. And we say when pressed, grab our HUD and remove from parent. Remove from parent means delete from the screen, not from RAM. If you're wondering why it's removed from parent, you have to ask the people at Unreal Engine. Why is this not saving? My hard drive get on points? Oh, it's because I have 2 instances of this project open. There we go. So start the game, it's on screen, press E, it goes away. And we can even go back into here and do a variable called is on screen. Put it here. If on screen is false, let's put it back on the screen. So add to viewport. And then we're going to set is on the screen to true. And if it is on screen, we'll remove it from parent and set is on screen to false. So now you have an inventory menu, basically. Like you can, pull it up and remove it as you please. Cool. Okay. But yeah, so storing it in a variable, always correct. It takes up no processing whatsoever, and it's just super nice to have. All right. So we're gonna go back into our widget, and we're gonna animate this guy for a second. We already talked about how to do this. I'm just gonna quickly grab it, brackets, text, and let's do an opacity animation because it's really easy to see. From 1 to 0. Okay. So an animation has to be called. It doesn't just happen. It's not like when you start the widget, everything's just going to start collapsing in and of itself. So what we can do first is event construct is the same as begin play. Basically, when this widget is created, doesn't matter if the player can see it or not. All the things here will happen. So we'll do play animation. And our animations are going to be over here. So we call this one animation storage. Target's going to be ourselves because we have the code in it already. Start time 0. We don't want to start arbitrarily. You can loop it. If you put 0, I believe it loops forever. If you put 1, it'll play it once, 10, 10, etc. Backwards or forwards. Ping pong, it'll do back and forth. If you're making a throbber, ping pong is going to be useful for that. And then the speed of it. So if I begin play, should just go hello and fade away. But again, that's kind of worthless. What we should be doing instead is making events. So we're going to do custom event, play animation. You might not like that I call this play our animation. Plug this in, nothing's going to happen. But we can go to our character and say when they press the W key, think it's gonna be faster if I just press input. Give me anything I can work with here. Mouse input, sure. Yeah, mouse events. When I left mouse button, we'll do that. Grab our HUD variable, play our animation. And so you see that with this variable, we can call events in there, and we can have the player driving all the code, and the HUD is just storage for it. Starts fading away when I press the left click. Okay. Binding. So I'm going to go into our character. I've already coded this just for ease, but I'm going to explain everything already. So I have a variable called ammo, and when I fire projectile, it's going to check if ammo is above 0. If it is above 0, we're going to subtract 1 from it. So if I have 100 ammo, go to 99 ammo. It'll shoot our projectile, which you don't need to worry about if you have the first person projectile in Unreal Starter Kit. This is all code you already have. So the only thing that's actually new here is if ammo is above 0, subtract 1. And now we're going to do some binding. So we'll go get our widget here. Get rid of this hello who needs it. This is going to be pissed at me, so let me delete this. Grab a progress bar. Anchor it to the bottom of our screen. I know I said anchoring was bad, but I'm working quickly here. And bind this. So binded the color. I want to bind the fill. So we're going to have a function here. By the way, it's going to always name them get%. You should make sure you're naming things properly or it gets out of hand very quickly. We're going to call this ammo counter. And so we have the ability to get from our player to reference the widget because our player created the widget. But our widget isn't going to create our player, like it's chicken and the egg situation. Only one of those can happen. So this is where casting comes in. Casting says, if you know where something is, you can transfer data between them. But if you don't know where it is, you can't. If I say I want the health of enemy number 3, well, if I tell Unreal, look for all enemies, there could be thousands in the map. It doesn't know which one it is. So you need to find a way to point to that specific one. Again, we're actually technically casting by creating the HUD and calling it, but we know where it is. It's the widget we created and called HUD. This is the one we're going to reference. If we're going to get something from the player character, Unreal's kind of helped you out here. You can do get player character. And we're going to do cast the first person character. So we're telling Unreal, find the first person character. And the one we want to find is the player's character, because we could have thousands of first person characters, but we want the player's character. And then from here, we're going to do get ammo. Like I mentioned earlier, progress bars are on a 0 to 1 scale, but because we have 100 ammo, we're going to divide this by 100. This is also why you should always work in floats, even if it's something like ammo, where you would never have 0.5 ammo. It just makes your math easier if everything's in floats. For those who don't know, floats are numbers with decimals, otherwise you just have an integer. So we have our thing getting called onto our screen, have our progress bar, hit play. You saw the progress bar was going down 1 by 1. And that's it, actually. I kind of sped through it, but that's all you really need to know in terms of widgets. I'm glad to just code some stuff in front of y'all if you want to see how it works, but otherwise you are ready to go. I will take questions from either of my 2 audience members. Cool. All right, I'm going to kill the recording then. If you're watching at home or on a recording later, thank you so much. Please join the GDM. I need to show this thing for flex, 1 second. Here is our contact information for the GDN server. That's my student email. I'm going to leave it on screen until I kill the recording. Please feel free to email me. I'm always glad to answer questions. Go check out our previous Unreal Engine talk hosted by our Vice President, Jessica Teague. There's also apparently talks about substance and immersive reality. Sounds fun. I didn't go to them. And thank you. Goodbye.